everybody. So today is Friday, April 5th. Today we're supposed to start 10.2, but we will start 10.1 today. And as you know, we are behind schedule. So we don't have time to do study session in the class. But I hope to do study sessions outside of class. But the fact is, last time when I did study session, nobody came. So I want to ask you, do you want a study session outside of class, like afternoon after 3:10 to 5? Do you want it?
Honestly, I think like a video, like you go over like the problems on the practice exam would be like a good one.
Oh, videos.
Yeah, because then like we don't have to if we do have questions, we can come ask it.
Oh, okay. But let me ask: everybody think the same way? So he suggests that I make a video about me going over all the problems on the practice exam, and it's time consuming. Yeah. So because I have all the solution, I would prefer you look at a solution, and if each step you don't understand, you come to see me because I write all the solutions. Because if I make a video, you just see me copy down like letter by letter, exactly the same thing as my solution. So that might not be the thing, because if you don't understand some steps, you might want me to explain more. So like what prerequisite knowledge or what formula I use that you might forget. So I would say like maybe in the video maybe just you see writing down the solution, just the same thing. Mhm. So we're talking about whether you want to have a study session outside of class next week. So because last time nobody came, so I want to ask you, do you want? Okay, if you want to have a study session, raise your hand. If you think you can attend the study session, raise your hand.
So I don't think I can.
What time?
Like maybe Monday or Wednesday afternoon, like from 3:10 to 5. Oh, how about other time? So I have time from 10 to 1:50. Is it about the time, or you think you rather study on
For me,
your own?
it's time. Otherwise, I come.
Oh, okay.
Yeah.
How about other people?
I can't do that. So.
You cannot do afternoon?
Yeah, because like scheduling, like I have like lists and stuff. Like,
Oh, so but do you mean morning? Like I do have time from 11 to 12, 11 to 1:50. How about other people?
I'm only free in the afternoon.
You only free in the afternoon? Okay. How about that? Because we only have like not many students here. I will be in my office a lot of time. So feel free to do your like practice exam or your homework in the table. When you have questions, just feel free to come and ask me. So then everybody you can come. And to be honest, I don't have many students ask me questions. So I'm always there waiting for you to come and ask me questions. Okay? So we don't have a fixed time study session, but I hope you can study with me. Come to ask me questions. Okay? All right. Yes. And it covers 9.3 to 9.6. Mm-hmm. So you still have the chapter 9 concept map. Mm-hmm. So it's about 9.3 to 9.6. So I want to like briefly review those methods with you. So 9.3, we talk about maximum and minimum. Okay, so what does that mean? So this is something new, like not in your sheets. I just decided to draw it. So you have a surface. You want to find the maximum or minimum of the surface. So what do you need? You need the first derivatives and all the second derivatives. And you need to compute the d. So you first find the first derivatives, set them equal to 0, and you solve the system of equations. Okay, everybody? And then you compute all the second derivatives, and you get the d. And at each point of your solutions, okay? So you get a system of equations. You solve the solution, you get some points. For each point, you plug in the d to see whether the d is positive or negative. Okay, and you decide whether it's a local mass, mean, or saddle point. This is 9.3. 9.4, Lagrange multiplier. What we are doing, we have a surface, but we have a constraint. So the surface is the function f. The constraint is the g. Everybody look at me. The constraint is the g. And what you're doing is like you have your g and it cut the surface into a curve in space. And you are looking for the maximum or minimum of this curve. Do you see this maximum or minimum might not be the maximum of the surface? So they are different things. So I graded your quiz. I realized some of you confused with the Lagrange multiplier and the method, the secondary test for find the maximum and minimum. And for the Lagrange multiplier, you just need the first derivative. Do you take a second derivative or plug in your d? No. Okay, so don't do that. So what you want to do is you compare the gradient vector of f and g. You set up the system. Gradient of f equals lambda times gradient of g. And also the constraint, g of xy equal to 0. Okay? And you have lambda. So usually, how do you get rid of lambda? Maybe you can use equation 1 divided by equation 2 to get rid of lambda. And you get a relation between x and y. You can plug in the third equation and solve for the x and y. Okay. And if you get several solutions, you put all of them in F. Okay? The biggest number is the maximum. The smallest number is the minimum. That is when you have more than one solution. But if you only have one solution, there's no other point you can compare to see this is a maximum mean. Then what do? Is you find another point in the constraint and plug it into F and compare with your solution. So everybody clear about this? Okay. And 9.5, the total differential. So dz is fx dx plus fy dy. Okay, if you have a function of 3 variables, dw, similar fx dx, fy dy plus fz dz. And the change of z is f of the final points minus f of the initial points. And absolute error is the difference of them. Is that okay, everybody? And 9.6, double integral. When you integrate from the inside to the outside. Right, everybody? But when you want to draw the region, you look at the outer variable. For example, dx, then you draw the little width, dx, and then you get a little rectangle. Y is a function of x. Okay? And how about if your dy is outside, you draw the little width dy, and then you have the rectangle. It's a horizontal rectangle, and this one. Okay, so you draw the little rectangle, you get x as a function of y. And the average value is the double integral over the average of the region on the xy plane. And you don't need to worry about switching the order of integration. So if I give you the double integral with the bounds set up already, just integrate from the inside to the outside. Don't worry about switching the order. We don't have time to get into the deeper concepts. Okay, so this is the chapter 9.
Are we going to quiz today?
Yes, we will go over the quiz today. So right now, yes. So this is the quiz solution. So the first problem we have, this is the function, and you want to find the maximums. So what you do is you take the derivative with respect to x, and take the derivative with respect to y, and you set them equal to 0. And because these problems, you can solve for y in terms of x, yeah, and plug in the second one, and you get x is 640 over 47, around 13.62. And then you plug in the y, you get a point. Okay, you get a point. This is a solution, but you don't know whether this is a max or min or saddle point. So you need to compute the d. So all the second derivatives, because this problem is easy, so all the second derivatives, they're just constants. But like in class examples, if you have higher power, the second derivative might have x and y. So when you plug in different point, you might get different d. Okay? So it just happened this example, the d is a 47, is positive, and the rxx is negative. So all the direction concave down, we get a maximum. But in the exam, you might have more than 1 point, and your second derivatives, you might have x or y. Okay, number 2. Use the Lagrange multiplier method to find the maximum mean of the function subject to the constraint. And so what you do is you have your f, and your g is the left-hand side minus the right-hand side. You compute the gradient of f. Do you see 5xy? The derivative with respect to x is 5y. The derivative with respect to y is 5x. And then the gradient of g is 1, 2. So you plug in and you realize equation 2 over equation 1, you get the 5 cancel. So x over y is 2. X is 2y. Plug into the third one, you get the y is 1. So you get the point 2, 2. Sorry, 2, 1. And this is the either maximum or minimum. We don't know yet. But the problem said find the relative maximum value or minimum value. This means you plug in f. So you plug 2, 1 in f, you get 10. Because you only have one solution, how do you know this is maximum mean? So I give you hints. Find another point on the constraint. So usually I pick x is 0, or you can pick y is 0. And then I find the point 0, 2 is on the constraint, and we plug in f. Do you see we get 0? So 0 is smaller than 10. So therefore, the 2, 1 is a relative maximum. So this is the quiz. Now let's look at mistakes. Okay, so I hope you can learn from the mistake, and then you can do well on the exams. Okay, so let's see. Where is it? Okay, quiz 4 mistake. Okay, so this is good. Just here, this is 48 minus 1, so 47. So it's very tiny mistake. And then here, your setup is right. I suggest you try to avoid working with fractions, because when you work with fractions, it's very easy to make mistake. So like here, you can leave it as 200 minus x is 6y, and then plug in the y here. So you work with the integers. But the method is correct. Yeah, so if you get the x and then you plug in the y and then you get the number. Okay, yeah, and yeah, the method is correct. Here, see, x over y is 2, so x is 2y, not y is 2x. So the method is right. So just one mistake. And after you find the points, you need to plug it up, and you need to show y is the maximum. So you need to find another point in the constraint and plug in that and compare with this number. Okay, so here, d. How do you get d? What is your second derivatives? Okay, so in the exam, show all your work. All your work has points. So find what's the rxx, ryy, rxy, and then compute the d. And okay, so here, this method is not Lagrange multiplier. Yeah, you can solve for x in terms of y and then plug in f. You get a function of a single variable then like what you did in applied Cal 1, you can take the derivative and find the critical points. But this method is not a Lagrange multiplier. This problem, because the problem is easy, you can use this method from Cal 1. But if I give you a harder problem, you might not be able to use this method because you might not be able to solve a y in terms of x or solve a x in terms of y. So the method is more important. So that's why here, even though you get the correct answer, but the test, I will make sure I would say use the method of Lagrange multiplier to find the following. Okay? So you gotta use that method. All right, and then here the setup is right, is just some mistake. And then here, set those equal to 0 and find the x and y. So if you don't give the point, where is the maximum? Yeah, you know there is a maximum, but where is it? And then here, derivative with respect to x is 1. Okay. And then here, so D is positive. What is your conclusion? It's a local maximum. And then here, don't compute the second derivative, okay? The second derivative is only for when you find the maximum or minimum of a surface. The Lagrange multiplier, you don't need the second derivatives. So be careful, don't get confused. So I hope you learn from the mistake and then do well on the exams. Okay, mistake is our teacher. It helps us improve. Sometimes I make mistakes too, so it's okay to make mistakes. All right, and then here, because there's a here means a minus sign, so that's why the answer is wrong. And when you take pictures, make sure you can see. And then yes, this is right. Derivative with respect to x. Derivative of x is 1, so we get 5y. Derivative with respect to y. Derivative of y is 1, so we get 5x. And I hope after you differentiate, check your setup, because if your setup is wrong, you cannot solve the system. Okay, so make sure you check your setup. And exam 3 is hard because the problem is long. If you mess up the setup, everything after is gonna be all wrong. That's why it's hard, because the problem is long. And each problem is about like 16 to 20 points. It's a lot of points. So I hope after you do the setup, check your setup 3 times before you continue. Okay, yes. Okay, any questions? Oh, okay, so here the mistake is, this is 6. So 2 times 3 is 6. So double check your setup. Okay. And then here, fxx, fyy minus fxy squared. So not multiply, minus. Okay. And then here the gradients is 5y and 5x. Okay. Any questions?
How are you going to point this on the test? Is it going to be like as you follow the steps?
Oh,
because like you said, if you get something wrong, you're going to be off kilter for the rest of it.
Oh, I still will give you like some partial credit.
So if you got
this.
everything right except for the answer.
Yes, then yes. Okay, so the practice exam is right here. So I list the points. You see, each problem is long, so it might take me three hours to make the video. But and when because I try to list all the steps here. Okay. So I hope when you read it, some step you don't understand, you can ask me. Okay, so very details. Okay, all right. By the way, in the exam, I might give you a picture so you have an idea whether you're doing right or wrong. But because I give you the picture, you cannot say, oh, from the picture. you show your work. Imagine you don't know the picture. Is that okay, everybody? All right. Okay, so and this is yes. So this is all the like the problems. Okay, I give you more than the exams. Okay, so you can see more exercise. Right. Okay. Any questions? How many questions are on the exams? Okay, let me. I would say less than that, but I don't quite remember. Let me see. If I just look at the first page, should be okay. You don't see the problems. All right, let's see. Okay, let's see exams. Okay, exam 3. Okay, 6. Mm-hmm. Okay. All right. Any questions about chapter 9? No? Okay. Good. I know our class is hard. This is the hardest math class. So I'm always here to help you. So come to my office, study with me. Okay, so let's see. Okay, let's go to 10.1. Okay, so yeah, depending on our schedule, we might not be able to cover so many about the 13.3. Okay, yeah, so we will see. So let's see. All right, so 10.1. Okay. All right. So yeah, after we went to Cal 1, Cal 2, Cal 3, now we come to the differential equation parts. So I feel like our course is like a buffet. You get a taste of different courses. So calculus 3, we talk about surface, and we did the maximum, minimum, and the double integral. And now we come to the differential equation parts. So 10.1, solution of elementary and separable differential equation. A differential equation, so 2 words, equation and differential. So it is an equation that contains an unknown function and one or more of its derivatives. Okay, for example, the following, so they are all equations and they contain the derivatives. Okay, the order of a differential equation is the order of the highest derivative that occurs in the equation. So, like, let's look at the order of the first one. So, what's the derivative? What's the order of the derivative? Y prime is just the first derivative, right, everybody? So, that's why here, this is the first order. Second one, do you see? Oh, that's the first derivative. And it's to the 6th power. And you also have the 4th derivative. When you talk about the order, it's not about the power. It's about the order of the derivative. So even though the first derivative is to the 6th power, do we look at the 6 to talk about the order? No, we look at the order of the derivatives, which is the 4th derivative. So this is the 4th order differential equation. Okay, how about the next one? What order? Prime. So it's the 2nd order differential equation. How about the last one? The derivatives. So which one?
Y to the 5th.
Yeah. So this is the 5th derivative. So this is the 5th order differential equation. So far, so good, everybody? All right. So, and then a function is called a solution of a differential equation if the equation is satisfied when y equals f of x and its derivatives are substituted into the equation. A differential equation together with the appropriate number of initial conditions is called the initial value problem. So the following is an initial value problem. So you have seen something like this in applied calc too. Do you remember like the story problem? You were given acceleration. You integrate acceleration to get the velocity, and you integrate the velocity to get the displacement. But every time when you integrate it, you get a constant c, right? So that's why the problem will also give you initial velocity and initial displacement. You can plug in and find the constants. Do you still remember those? Okay, so let's look at the following. We want to find solve the initial value problem. So we want to find the y. So the y is the integral of the y prime. So integral 10 e to the negative t over 2 dt. Ten times e to the negative t over 2 dt. So 10 is a constant multiple. Stays here. What's the integral of e to the ax dx? E to the ax over a plus c. Yes, everybody? So therefore, we have e to the negative t over 2 divided by, what's the coefficient of t? Negative 1/2. Right? And then plus c.
Why is it 1/2?
Oh.
T on top.
Oh, yes, because it's the coefficient. The variable is the t. And then the coefficient is negative 1/2. Right? So this is negative 1/2 times t. So t, compared to our formula, t is like the variable x.
That makes sense.
And then the a is the negative 1/2. And when you divide it by negative 1/2, it's the same as multiply by the reciprocal, which is negative 2. Right? And negative 2 times 10 is negative 20 e to the negative t over 2 plus c. Right, everybody? Okay, so this is the y. And we have a constant c. That's why we want to plug in the initial condition. So this means we plug in x is 0. And the y is 4, right? So y is 4. X is 0. Sorry, here the independent variable is t. So t is 0. Okay, so t is 0. We get e to the 0. What is e to the 0? 1. Oh, nice. What is c? You move the negative 20 to the other side, it becomes 24. So we add 20 on both sides. We get c is 24. Is that okay, everybody? So finally, y is negative 20 times e to the negative t over 2 plus 24. This is our solution. Okay. This is how to solve a differential equation of this type. If you have y prime on your left-hand side and your right-hand side is a function of t, you can just integrate. So integrate it. And after you integrate, you plug in the initial condition to find the constant c. Any questions? Okay, so Next one. If we have something like this, what do we do? Okay. Usually we want to isolate the dy dx. So isolate means we only want to have the dy dx on one side. So both sides we add 2x. We get dy dx equals 2x over square root of x squared plus 3 plus 2x. Right, everybody? Yeah, isolated dy dx. Ooh, do you see the left-hand side is just dy dx? By the way, it's the same as y prime. dy dx and y prime are the same thing. And then the right-hand side is a function of x. So we can integrate them. So we integrate. So y is the integral of the right-hand side. So far, so good, everybody? Okay, so integral. We learned 3 antiderivative formula. Yes, the integral of x to the n dx is x to the n what? Plus 1 over n plus 1 plus c, right? Or e to the ax, we already know that. And one more, integral of 1 over x is log x plus c. Okay? And therefore here, if you see something like that, do you see here the derivative of x squared is 2x? This is u substitution. U substitution. So we need to separate them. So we only do the u substitution on the first integral. So separate them. The second integral we can integrate. What is the integral of 2x? Yeah, x squared plus c. Good. To separate them. Okay? This integral, we need to use u substitution. Okay. U substitution. So you use u substitution usually when you see a composite function and you see something is the derivative of something. So we let u be x squared plus 3. Is that okay, everybody? And then du is what? 2x dx. Okay. And now we have, we're ready. Because then this guy equals integral 2x dx. That's the numerator. 2x dx is du, right? The denominator is what? Square root of u. Thanks, everybody. And this is, okay, we need to change to the standard form. This is u to the what power? Yeah, -1/2. Okay, what is the integral of u to the -1/2? U to the 1/2 over 1/2 is the same thing as 2. Yes, very good. And finally, what is u? Yes, x squared plus 3 is the u. Okay, so this is the first integral. Therefore, the y is the 2x squared plus 3 to the 1/2. and plus x squared, and then plus c. You only need plus c one time. You don't need to do plus c and plus c, and you don't need to do that. Okay? Because c is any constant. You only need one copy is enough. Okay, so this is the y. Everybody okay with this step? And now we want to find the c. So we plug in y of 1 is 8. So y is 8. X is 1. What is 1 squared? 1. 1 plus 3? 4. Oh, good. Okay, 1 squared is 1, right? What is 4 to the 1 half? 2. 2 times 2? 4. So this is 4. Okay, so we get 8 equals, what is 1 plus 4? Good. Then what is c? 3. Yes, very good. Subtract 5 on both sides. We get c is 3. So finally, our answer is 2 x squared plus 3 to the 1 half plus x squared plus 3. Is that okay, everybody? All right. Okay. Also, by the way, because we don't have much class time, so most of our time is just lecture. I hope you're okay with that. If I have more time, I will hope to do one example and then you do 2 examples. That's the ideal world. But unfortunately, we don't have that much time. So, and you know, our last chapter, our problems was so long, so we don't have time to do like enough examples in class. We have to talk about some idea of some examples, and I ask you to watch the notes on the website. Okay, so but this means after class, I hope you can get more practice. Even though you don't have time to practice in class, I hope you can practice outside of class. And I'm always in my office waiting for you to come to ask me questions. Okay, so verify that y is the solution of the differential equation. Part B, find the value c for which the solution satisfies the initial condition y of 0 equals to 5. Okay, so this problem, do you see we have the dy dx and we also have y. So we cannot use the previous method because the previous method you isolate the dy dx and you get your right hand side is just a function of x. So we can integrate. But this problem, if you isolate the dy dx, on the other side is a function of x and y. You're not able to integrate x and y within the same integral. Okay, we cannot do that. So we need other method. But this problem, it just asks us to verify this function is a solution. So verify means you find the derivative and you know the y. Then you plug in the equation to see whether the left-hand side equals the right-hand side. Okay, so let's see. What is the derivative? So what's the derivative of e to the x? 1 times e to the x, right? So it's still negative 1 over 4 e to the x. And what is the derivative of c? So c is a constant multiple. What's the derivative of e to the 3x? Over 3, or now we're taking derivative, not, multiply by 3. So in this process, sometimes you differentiate, sometimes you integrate. So make sure you Check what you're doing. Derivative. So multiply by 3. Don't divide it by 3. So this is the derivative. Now we are ready to plug in. Left hand side is 2 times y prime. So y prime is this negative 1/4 e to the x plus 3c e to the 3x. Usually they like to put the number in front of a letter. Okay, that's why I switched the order of it. But if you don't like to switch the order, that's totally fine. You're correct. And then minus. See, we plug in. This is the y prime. And then minus, do you see 6? Yeah. And then times the y. What's the y? Negative e to the x. Yes, this is the y. Yeah, everybody? Negative e to the x over 4 plus c times e to the 3x. Is that okay, everybody? We're plugging y prime and we're plugging y. Oh, we still have negative e to the x. Let's calculate it. What is 2 times negative 1/4? Yes. 2 over 4 is 1/2. Yes. So 1/2 e to the x. And 2 times 3 is 6c e to the 3x. Right, everybody? And then next, okay, what is negative 6 times negative 1 over 4 e to the x? Minus minus multiply, we get plus 3 over 2 e to the x. Minus 6 times c is negative 6c e to the 3x. Right? And we also have the minus e to the x. What happened? Yeah, 6c e to the 3x cancel. And what? Negative 1/2 e to the x and negative 1 e to the x together is negative 3/2 e to the x. Yes. So they all cancel. We get 0. And 0 is the right hand side. Check. This is a solution. Because when you plug in the differential equation, the left hand side equals the right hand side. Okay, everybody? So y is a solution. That's part A. Part B. You can do part B. What? X is 0 and the y is 5 to find the C. So this part you can do it. What is the C? That's the solution up there. You plug in x is 0 and y is 5. All right, let's check our answers. So this is 10.1. All right, so we plug in the y is 5 and the x is 0. So e to the 0 is 1. So negative 1 over 4 plus c is 5. Therefore, c is 5 plus 1 over 4, which is 21 over 4. Do you have the same answer? Okay, good. Depending on the problem, because the problem said find the value of c. Yeah. But the previous problem said solve the differential equation. Then they want you to express your solution. Y equals what? Good. Okay, and so all these is like we kind of learned before. We know what is the y prime, and then we integrate to get the y. Okay, the next type of differential equation is called a separable differential equation. So when you solve for isolated dy dx, you see your right hand side. It's not just x, it has y. But however, the right hand side can be expressed as a product of a function of x and a function of y. Okay, everybody? So even though your right hand side has the y, but you can separate the x function multiplied by the y function. Okay? So this is called separable. You can separate the x and the y. So if we have something like this, you want to move all the y to the left-hand side. And you want to move all the x to the right-hand side. So, by the way, when I say move, I mean either multiply or divide. Look at this. Do you see here? By the way, you can define h of y be 1 over f of y. Okay, then your right hand side will look like g of x, and then over that. So when you move, you both sides multiply by h of y. Okay, so you got okay right here. Oh, maybe we don't do this. Okay, let's look at this. When you move means either multiply or divide. Okay, so you want to move the y to the other side, you both sides divided by f of y. And when you want to move the x to the right hand side, do you see you have the dx here? So you kind of both sides multiply by dx. You get 1 over f of y dy is g of x dx. Is that okay, everybody? Yeah, we both sides divided by f of y. So we move the y to the left. We both sides multiply by dx. We move the dx on the other side. So now you see all the y is on the left-hand side and all the x is on the right-hand side. You can then integrate them respectively. Okay, so separately. Then, yes, this is the method of separable differential equation. And next class, we will work on it. Okay? So have a nice weekend. So you can start working on the practice exams. And next week, I hope to see you more often. You'll come to ask me questions about your homework, the practice exams. Yeah, and on Monday you have the homework 9.5, 9.62, and also quiz 5 on those 2 sessions. Okay, bye. You're welcome. Have a good day.